Let's see how we can efficiently trace our signals using Riviera-PRO graphical debugging tools. Let me initialize and run my simulation using partial script select. Now that my simulation has started, let me switch to the debug perspective and take a look at my waveform. For example, this signal, LED A. Let's see if I wanted to take a look at its driver. I could double click on that signal, which would take me to the declaration in the source code. Now when I put my mouse over it, I can see a prompt, which if I open, I can see that I can add this signal to drivers and readers viewer. This is the one I'm gonna need to trace the signal at the code level. Drivers and readers viewer has two parts here. The upper one shows the driver information, while the bottom one shows the reader information of that current signal. And it also helps by showing the name of that driver, which could be slightly different or completely different from my signal I'm exploring. So in this case, LED A is being driven by LED signal. If I double click on this process, it opens up a different file because it's located at a different level, and I can see that LED signal now is being assigned some constant values depending on the hex signal. So essentially hex is driving the values that are assigned to LED. Now I wanted to take it further and explore the drivers of hex signal, but when I put my mouse, as you can see, the prompt doesn't come up. The reason why is because the simulator is not located or is not focused on that current scope of this new level that I have opened. So to fix that, I can just set a breakpoint and make sure that I run my simulation to hit that breakpoint. If my simulation has ended, like it did, I would need to restart and run it. Okay, here I did hit my breakpoint. Now if I put my mouse, it immediately comes up and I can add my hex signal to drivers and readers. And actually that's the case I was talking to. Now hex is connected to BCDD at a different level, so let me take it further. Now BCDD is connected to some other signal, which again I need to set the breakpoint and run it a little longer, clear the breakpoint that I don't need. Okay, now I'm at the place where I need to be. Now add BCDDI to drivers and readers. Double click, and I do see some process where BCDI is being reset. Scrolling down, I can see that okay, it's been assigned values of some BCD signal. So let's add that, and the number of the process seems to be the same, 32. That's the line number actually. And if I do scroll down, I see that okay, it's under this branch, it's just correction, and here BCD is assigned, it's a shift register basically, and the least significant bit is then assigned some other bit over here. So it seems like the BCD signal is the end of that chain, and it's just a shift register. Now let me verify this theory of mine. It's when you look at the code, you may miss a driver because it can be located somewhere down below or even at a different level. So let me add this to a truly graphical tool. At this time I'll select Add to Advanced Dataflow, which Advanced Dataflow show me this in RTL-like view or a schematic capture-like view. And I do see that BCDD highlighted currently is not connecting to anything but itself. Let me switch to the documents perspective so that I can get most of the space. And well, yeah, that does prove my theory that BCDDI that was connected to this process that's been driven by this process is then driven by BCDD signal, which is a shift register. Now that I'm in Advanced Dataflow, let me show you some of the power features of Advanced Dataflow. You can also, similarly to drivers and readers, find out the drivers of any signal by right-clicking and selecting Expand Net to Drivers. so it opens it up to the driving process, and you can do the opposite, the same in the opposite direction. So for instance, if actually we already looked at BCDDI, so let me just double click on that, and it'll open it to the process that's reading the values, and I can take it further, right click, and expand it to the next level reader, so on and so forth. If I double click on the net without specifying if I want to see driver or reader, it'll show me both, and I can take a look at the values. Now let's say if I was exploring the dependency of signals and how they affect it, how inputs affect the outputs, I could add all of these signals, or signals that are connected to the current level, to the waveform viewer. Let me show you that. All you need to do is just click somewhere in that area that will highlight the boundaries of my unit, of my instance that I'm looking at, and see it's a UUT /U2 instance path, and I can add to the waveform signals that are connected to that instance. And here I can see now my UUT U2 signals being added. Let me go ahead and run the simulation. I hit my breakpoint that I set a few seconds ago, so let me clear that. That'll let me complete my simulation. Go back to the debug here. Here, now I do see my signals on the waveform, and I can explore the values and see also the relationship between those signals. When looking at the waveform, one thing that is important is that the position at which the cursor is set, defining the source point of the values that are showing in the advanced data flow. So for example, if I want to look at this particular time where lots of events happening, let me do that by setting my cursor, and let's say bin input, let me set my cursor at 0B0. When I go back to advanced data flow, I do see that my B input is showing me the value from that specific time. And now if I go back to the waveform and move my cursor to the right, I can see that this is reflected now, not only in this signal, in all of the signals in my advanced data flow. So it's important to remember and to know that the position of the cursor on the waveform actually defines which values you see. So if you want to go back in time or go to the current time, you can do it very easily by setting your cursor. And so again, just summarizing, drivers and readers and the advanced data flow are one of the most efficient ways to trace your signals, and connection and cross-probing with the waveform makes it even more powerful.